Hello everyone. In this video, I am solving an example from chapter 14, gas vapor mixture. So there is no problem statement. It's pretty short. I can just write it down. So let's say for the dry bulb temperature, TDB, dry bulb, temperature of 26 degrees C, and for wet bulb temperature, WB, of 21 degrees C, and also for the atmospheric pressure of 100 kPa. The question in part A is asking for the absolute humidity or omega. Okay, so in the previous video we discussed about the dry bulb temperature and the wet bulb temperature. What you want to do, you want to use the discussion we had in this schematic. Okay, so just to briefly review what we had here. So the whole purpose of this concept or experiment is to obtain the absolute humidity of this stream. So this stream is, let's say, atmospheric air, meaning that this is the combination of dry air and water vapor. And the goal is to obtain this omega 1. This is exactly what we have here, right? We are looking for omega, or absolute humidity. Now, we have a bunch of definitions. The temperature that we have in the air is the dry bulb temperature. So this T1 is the dry bulb temperature. T2 is wet bulb temperature, simply because this channel or this container is long enough that gives us a relative humidity of 100% in the exit. So because of that, T2 is wet bulb temperature. All right. And so the other thing we had here was this equation. So this is the equation that I'm going to use. In this equation, we are solving for omega 1, all right? But in order to obtain omega 1, we need to have omega 2 right here. And this is the equation that we are going to use to omega 2. So the procedure is first obtain omega 2 based on these properties, then put the omega 2 value here and obtain omega 1. All right. The only thing that you want to know is about the subscripts 1 and 2. So once again, the subscript 1 refers to the dry bulb condition or the dry bulb temperature, and subscript 2 refers to wet bulb condition. That's it. Okay. So let's do that. What I'm going to do, as I said, I'm going to obtain omega 2, okay? And again, maybe omega 2 doesn't really make sense in this combination. Subscript 2 refers to wet bulb condition. So basically 2 is the same as wet bulb. But regardless, omega 2 is going to be equal to 0.622 Pg2. By the way, there is absolutely no point in memorizing all these equations. I'm looking at my notes. P2 over Pg2. Okay, now the question is, what is Pg2? What is P2? Okay, so Pg2 is the saturation pressure at wet bulb temperature. Okay, so this is Psat at temperature equal to 21 degrees C. So you go to table and you obtain that Tsat, which is equal to 2.5 kPa. So this is Pg2, the same thing here. What about P2? P2 is the total pressure we have in the exit. So the total pressure in the exit is the same as the total pressure in the inlet, and that is 100 kPa. Okay, so don't forget that the total pressure is equal to the dry air pressure plus the vapor pressure. All right, so if I put in numbers, I can solve for omega 2, and that will be 0.622 multiplied by 2.5 kPa over 100 minus 2.5 kPa, and that gives me absolute humidity of 0.0159 kilogram water, or water vapor I should say, over kilogram dry air. Now, this is not the question is asking for. This omega that the question is asking for is omega for the dry bulb temperature. So that means I want to put this into the other equation, and the other equation is omega 1 equal to Cp T2 minus T1 plus omega 2 HFG2 over Hg1 minus Hg2 F2. All right. So once again, the subscript 2 refers for this condition. So maybe I can say here this is for subscript 2. All right. And this one refers to the subscript 1. Subscript 1. So that means this HFG2 is evaluated at 21 degrees C. T2 is 21 degrees C. T1 is 26 degrees C. Don't worry if that is a negative value. Okay, that's the way it is. HG1 is HG at 26 degrees C. Okay, so this HG comes from water table. This HFG comes from water table, I think A4. Same thing here, A4. HF also comes from water table. But this is at subscript 2, which is 21 degrees C. Okay, so subscripts 2 are 21 degrees C and subscript 1 is 26 degrees C. All right, so it is going to be equal to point. This CP is a specific heat. So that is 1.005, 21 minus 26, and the unit for CP is kilojoule per kilogram Kelvin. This is degree C plus omega 2, we just found that, 0.0159 kilogram H2O over kilogram dry air multiplied by HFG2. So you go to table A4 and you need to do an interpolation to obtain it for 21 degrees C, but it should be equal to 2451.1 kilojoule per kilogram, right? And in the denominator you have HG1, which is 2548.3 minus 88 kilojoule per kilogram. All right, so this CP is the specific heat for air, which is this value. All right, so that gives you omega 1 equal to 0.0138 kilogram water vapor over a kilogram dry air. So this simply means if you have this condition in the room, if your dry bulb temperature is 26 degrees C and your wet bulb temperature is 21 degrees C, this is the amount of moisture content that you have for each 1 kilogram of dry air within the room. Now in that room, there can be a certain amount of dry air, right? For each 1 kilogram of that dry air, we have this much of water vapor. So what is this dry bulb temperature? The dry bulb temperature is the temperature that you measure with a regular thermometer. The wet bulb temperature is a temperature that you measure with a thermometer, but in that thermometer there is a wet wick around the bulb, as I said before. So let's say this is a thermometer, the blue thing is a thermometer, and around the bulb we have a wet wick, okay, and there is air blowing into this thermometer. So the temperature that this thermometer reads is the wet bulb temperature. Okay, and we need this sort of measurement as well as the regular measurement to be able to obtain the moisture content within the air. So that was the answer to part A. In part B, the question is asking for relative humidity. So this is relative humidity, and relative humidity is basically the ratio of mass of vapor to the maximum moisture content that air can hold within that temperature. All right. There are different equations for that. The one that we can use for this part is relative humidity is equal to omega 1 P1 over 0.622 plus omega 1 multiplied by PG1. So what is PG1? So PG is Psat at the dry bulb temperature. So this is P sat at 26 degrees C. All right. So value wise, this comes from table. So value wise, this is equal to 3.38 kPa, and this comes from table A4 with some interpolation because this temperature is not listed. So this is checked. Omega 1 is known, it's right here. P1 is the pressure, the total pressure. This is 100 kPa. So this is known, this is known, this is known, and omega 1 is also known. So everything is known, right? So relative humidity is equal to 0.0138 kilogram H2O over kilogram dry air multiplied by P1, which is 100 kPa, over 0.622 plus 0.01, I'm sorry, plus, yeah, that is correct, 0.0138, okay, multiplied by PG1, which is 3.38 kPa. All right, and that gives you a relative humidity of 0.642. Or if you want to report the relative humidity in percentage, that is probably more common, is 64.2%. All right. Now, in part C, the question is asking for the dew point temperature. Okay. T subscript dP is question mark. So this subscript dP stands for dew point. So subscript dP may be kind of similar to dB. The dB subscript is the dry bulb, all right? B as in boy here, but here we have dP, dew point. What does dew point mean? The dew point temperature is the temperature at which condensation occurs at a constant pressure, all right? So basically, the dew point temperature is the saturation temperature at the vapor pressure. So TdP is T sat at vapor pressure, PV. So I want to find the vapor pressure in this room. The vapor pressure can be obtained based on relative humidity. So relative humidity is vapor pressure over the saturation pressure. Okay, so this saturation pressure is evaluated at the dry bulb temperature. So this is at T dry bulb. So P sat, the saturation pressure, is evaluated at dry bulb temperature, which is 26 degrees C. All right. So that means the relative humidity that we just found, which is 0.642, is equal to the vapor pressure over the saturation pressure at the dry bulb temperature. The dry bulb temperature, once again, is 26 degrees C. And the saturation pressure, we found it here, is 3.38. So that means our vapor pressure is 2.16 kPa. But the reason that I found vapor pressure is because I want to use this vapor pressure to obtain the dew point temperature. The dew point temperature is the saturation temperature at the vapor pressure. So these two gives me a conclusion that T dew point is equal to the saturation temperature at 2.16 kPa, which is equal to 18.58 degrees C. So once again, this comes from table A5 this time, because this time we have the pressure. So you want to find the saturation temperature for that. So the dew point temperature at the end of the day is 18.58 degrees C. So this temperature simply means if the temperature of the room drops below this temperature, let's say if we have a temperature of 17 degrees C, then we have lots of condensation in that room. For any temperature below this much, we have condensation. All right, that's the definition of dew point temperature. Okay, so for the last part, part D, the question is asking for the enthalpy. Okay, and in order to obtain enthalpy, I'm going to use equation enthalpy is equal to enthalpy of dry air plus omega multiplied by Hg. Okay, so this is the enthalpy of dry air. And this is the absolute humidity we obtained in part A, which is basically omega 1. And Hg is also evaluated at dry bulb temperature. So this is at T1. So in order to obtain the enthalpy of dry air, I can just use Cp multiplied by temperature. So H is equal to Cp multiplied by temperature plus just keep omega Hg. All right. So this temperature here is probably the only exception we have in thermodynamics, and this needs to be in degree C. In degree C. So this gives me H equal to 1.005 kilojoule per kilogram. You can say Kelvin or degree C, both of them are the same, multiplied by temperature. This is T1, this is the dry bulb temperature, so 26 degrees C, plus omega 1, here we obtained it in part A, and that was 0.1, I'm sorry, 0.013, okay, so let me check. Yeah, that was 0.0138 kilogram H2O over kilogram dry air multiplied by Hg. So this Hg is also evaluated at T1, or at dry bulb temperature, let's say. So at dry bulb temperature, the value of Hg is 2548.3 kilojoule per kilogram. So if you do the math, the answer is 1.005 multiplied by 26 plus 0.0138 multiplied by 25, 48.3, and that is 61.76 kilojoule per kilogram. All right? So this is the answer for enthalpy. Now, the only point about the unit here is about this kilogram. We want to be careful. This is kilojoule per kilogram of dry air, right? Simply because this part was for dry air, and also here, which is for water vapor, this is kilogram dry air. So in fact, H is kilojoule per kilogram of dry air. This simply means for each 1 kilogram of dry air, the enthalpy of the mixture, which is the mixture of dry air and water vapor, is 61.76 kilojoule.